Hello viewers, you're welcome to another lesson. In this tutorial, we will learn how to solve quadratic equation by completing the square method. Very simple and very easy to understand. Just understand the steps. You can write it down in the book so that you follow up properly. Let's get started. So we have a quadratic equation on the board, and how do I know this is a quadratic? Because the highest power of the unknown variable is 2, so it is quadratic. And when you solve a quadratic equation, you end up with 2 roots for that equation. So let's get started. Step 1. If there is a coefficient of s squared that is not 1, you divide both sides by that coefficient. Here, the coefficient of s squared is 2, so we divide both sides by 2 in order to eliminate this coefficient of s squared here. So we have divide by 2, divide by 2, divide by 2, divide by 2. Don't be afraid to divide 0 by 2, okay? So this will go out with this. We have x squared plus 10 upon 2 is 5x, 12 upon 2 is 6, equal to 0 upon 2 is still 0, okay? Yeah, it's 0. Now, step 2, we pick the coefficient of x, which is 5 here. We divide by 2 and we square it. It's a rule. We pick the coefficient of x, which is 5. We divide it by 2 and we square it. Okay, it's a rule. Okay, that is a rule. It's a method to complete the square. So when we get this term, the natural thing we do with it is we add it to both sides of the equation. But I'm going to show you a step before adding it to both sides of the equation. Just watch. So with this term, I'm going to have s squared plus 5x, that's this guy, then plus 5 over 2 squared, then minus 5 over 2 squared plus 6 equal to 0. Okay, what I just did is like as if I'm subtracting these two terms. Of course, this minus this is 0 and back to this previous equation. So completing the square naturally do not alter the equation. The equation still remain what it is, but we're actually doing a very serious business here right now. So now looking at this equation we have here, the 3 terms I need in the left hand side is this, this, and this. So I'm going to take away these 2 guys to the other side of the equation. So I'm going to have s squared plus 5x plus 5 over 2 squared equal to, when this man goes over to the other side, because it's negative here, when you cross the positive side, it becomes positive. So I have 5 over 2 squared. Okay, it's positive now. Then when this one goes over, it becomes negative, so I have minus 6. Of course, 6 over 1 is sitting as 6, okay? Yes. Now, that is how to do it. As if you can now see clearly that we actually did add this term to both sides of the equation. You can see we are adding it here and we're adding it here. But this is the basic thing we need to understand, the essence of adding this term to both sides of the equation. Okay? Yes. Now, how do we simplify this left hand side? There's a trick for that, okay? Because if you look at this term, the extreme terms here have squared. X squared, 5 over 2 squared. So because of that, I'm going to open a bracket like this and I'm going to end it with squared, okay? So this term here, I'll put it here. So I have x here. This term, 5 over 2, I'll put it here. So I have 5 over 2 here. Then the sign here, I'll put it here. So when you expand this, you get this expression. So this is the compact form of this expression. So we are done with the left hand side. We'll go over to the right hand side. 5 squared is 25. 2 squared is 4 minus 6 over 1. Okay? To simplify this left hand side, these are fractions, we need to do the LCM. So let's move to the other side. Yes. Now, to simplify the left hand side, we take the LCM of these 2 denominators, and the LCM of 4 and 1 is simply 4. So we have 4 here. Okay, 4 into 4 is 1. 1 times 25 is 25. Minus 1 into 4 is 4. 4 times 6 is 24. Okay, 25 minus 24 is 1 upon 4. But remember, we have x plus 5 over 2 squared. So to remove this square here, we square root both sides. So we have x plus 5 over 2 equal to plus or minus square root of 1 over 4. Yes, this is the ideal way to square both sides. Yeah, this is the ideal way. and we really need this because we are looking for 2 results. So we'll finish up this side. We have x plus 5 over 2 is equal to plus or minus square root of 1. This is like square root of 1 upon square root of 4 from the law of surd. So we have square root of 1 is 1, square root of 4 is 2. So of course we have x plus 5 over 2 equal to plus or minus 1 over 2. We will collect like terms. So this 5 over 2 will go to this other side of the equation. And when it's moving over, the sign will change from positive to negative. So we have x is equal to negative 5 over 2. Then we have plus or minus 1 over 2. Okay, the sign of this guy will not change because it's not moving across the equality sign. Okay, so taking this equation to this side for clarity's sake, so I'm going to have, I'll pick the plus side first. So I'm going to have x1 is equal to minus 5 over 2 plus 1 over 2, or I'll pick the second side, x2, I'll pick the negative side is equal to minus 5 over 2 minus 1 over 2. So let's finish this stuff. Let's finish this one. We have x1 is equal to, the LCM of 2 and 2 is 2. But when they have the same denominator, they have common LCM. So we have minus 5 plus 1. Okay, so minus 5 plus 1 is minus 4 upon 2. And minus 4 upon 2 is simply minus 2. So x1 is minus 2. So let's get x2. x2 will be the same LCM is 2, like that. So we have minus 5 minus 1. So minus 5 minus 1 will give me minus 6 upon 2. Of course, negative 6 upon 2 is simply negative 3. So x2 is 3 while x1 is, x2 is negative 3 while x1 is negative 2. So these are the roots of this quadratic equation. Thank you for watching. God bless.